Hello and welcome to the second part of This is How It Works. In this second part, I will show you how you can build the IEC program and quickly use the provided automation framework templates to move the axis. We are here in a MOVISUITE project. The yellow notification triangle on the controller tells us that 3 user notifications are active. MOVISUITE prompts us to update the IEC project and adapt it to the axis configuration. To do so, we simply click the blue button and sit back while MOVISUITE updates the project. Firstly, the IEC Editor opens automatically. In addition to the project, MOVISUITE wants to update the configuration data too. MOVISUITE also creates a data backup for each axis and saves it on the controller. That makes it very easy to replace an axis later on. The controller will automatically transfer the data backup on the new axis when switching on. Lastly, MOVISUITE updates the IEC project in accordance with the details in the function view. The next step is to modify the user program. The template project originally had one conveyor modulo machine module and one pocket belt machine module. The pocket belt module is of no use to us and we delete it. The IEC editor uses red underlining to flag resulting errors. We can simply delete the pocket belt parts from the program. The conveyor modulo machine module is useful for our virtual master axis. We start changing the names one by one. The refactoration function in the IEC editor helps us to rename everything automatically. In the main program, we transfer no longer the global variable interface conveyor modulo, instead it's interface master modulo. We then also change the variable type within the function block. It's as easy as that. We now already have the first machine module, which we need for our form, fill and seal machine. The final part of this step is to compile the program to check whether our changes have been successful. To prepare the other machine modules, we can create our code template from scratch or modify a suitable existing template. We choose the second option because the Program Organization Units tab already has a number of prepared machine modules that are very good fit for our machine. We copy the 15 winder machine module from our POUs and paste it into devices. We also paste the FB winder and the FB winder system variable declarations from the template into the program automation framework. We then copy the system module call in the machine tree and add our program's machine tree. When adding the FB winder block located to the main program, Program Automation Framework main, to devices, we must adapt the 2 input variables underlined in red in this block. Since the winder block still has a call with the cycle of 1 milliseconds in the task priority, we must copy a block from POUs one final time. We use the current virtual master modulo speed as the master speed for the winder. The final step in this modification stage is to check that the refactoring of the variable names has also worked on the internal visualization pages. Done. Now we just need to log in. We start by scanning our controller. The green light on the right indicates we have a connection. We then log onto the controller with our program. Our program code has been compiled without any errors and transferred to the controller. Following initialization, our program is running and we can use the MasterStateMachine block's internal monitoring to perform diagnostics on our machine. Once the square at the bottom turns green, we can control the machine. The visualization is then almost like our own little operator panel. Let's start by jogging the axis. To do so, we switch to manual mode and then execute state. To give an example, I'd like to show you a demonstration of jogging the cross-sealing roller. In the rotary knife visualization, we can see the position of the sealing roller with its 2 knives and sealing jaws. As soon as we have called up the controller via monitor control, we can jog the sealing jaws in both directions. That all involved quite a bit of work, but the templates were a great help for the program code. In the final video, I'll be showing you how the machine operates in automatic mode. Thank you for joining me. I look forward to welcoming you back for the next part. See you soon.